In the fading light of the African savanna, a distinctive sound carries across the grasslands part cackle, part howl, wholly unmistakable. This is the voice of one of Earth's most misunderstood carnivores, the hyena, an animal whose intelligence rivals that of primates, whose social complexity exceeds that of most mammals, and whose ecological importance cannot be overstated, despite centuries of negative mythology and cultural prejudice. These remarkable creatures represent some of the most successful and sophisticated predators on the planet, with evolutionary adaptations that have allowed them to thrive for millions of years across diverse habitats from the deserts of Namibia to the mountains of Ethiopia. The family Hyaenidae comprises 4 living species, each occupying distinct ecological niches and exhibiting unique characteristics. The spotted hyena, scientifically known as Crocuta crocuta, reigns as the largest and most widespread member of the family, with individuals weighing between 50 and 79 kilograms and standing up to 90 centimeters at the shoulder. These powerful animals display a distinctive yellowish-brown coat covered with irregular oval spots, a bear-like build with rounded ears, and a bushy tail tipped in black. Current estimates place the global population between 27,000 and 47,000 individuals scattered across sub-Saharan Africa, making them the most abundant of the hyena species despite experiencing population declines outside protected areas. The striped hyena, Hyena, claims the title of most widely distributed hyena species, with a range extending from North Africa through the Middle East and into Central Asia and the Indian subcontinent. Smaller than their spotted cousins, striped hyenas typically weigh between 22 and 55 kilograms and display a light grey to straw-coloured coat marked with vertical black stripes along their sides and legs. Their most distinctive feature is a luxuriant mane that can reach up to 200 millimeters in length, running from head to tail base and capable of being raised to make the animal appear 30 to 38% larger when threatened, with fewer than 10,000 mature individuals remaining globally and a patchy, isolated distribution across their historic range. Striped hyenas face an uncertain future and carry the classification of near threatened on the International Union for Conservation of Nature Red List. The brown hyena, Parahyena brunnea, represents the rarest of the hyena species, with only 4,000 to 10,000 individuals surviving in the wild. These remarkable animals are confined to the arid regions of southern Africa, particularly the Kalahari Desert and the Skeleton Coast of Namibia, where they have adapted to survive in some of the harshest environments on Earth. Their long, shaggy dark brown to black fur, which can reach up to 30 centimeters in length, contrasts sharply with lighter tawny or cream-coloured fur on the neck and shoulders, creating a distinctive ruff. Brown hyenas show minimal sexual dimorphism, with both males and females weighing between 34 and 43 kilograms and standing 70 to 80 centimeters at the shoulder. The species exhibits extremely low genetic diversity, the lowest of all hyena species, with all sampled individuals showing identical mitochondrial DNA, a legacy of continuous population decline over approximately 1 million years, that accelerated at the end of the Pleistocene. The fourth member of the family, the aardwolf, Protals cristata, diverges dramatically from its bone-crushing relatives. This smallest member of the Hyenidae weighs a mere 7 to 15 kilograms and measures 55 to 80 centimeters in body length, despite superficially resembling a small, thin-striped hyena, with its yellowish-brown coat marked with vertical black stripes. The aardwolf occupies an entirely different ecological niche as a specialized insectivore. Its teeth have been reduced to flattened pegs, with the exception of sharp, well-developed canines retained for defense, the aardwolf maintains two geographically separate populations, one in southern Africa and another in East and Northeast Africa, separated by approximately 1,500 kilometers. These shy, nocturnal creatures can consume between 200,000 and 300,000 termites in a single night, using their long, sticky tongues to harvest their preferred prey. Termites of the genus Trinovitums. The anatomical features that distinguish hyenas from all other carnivores begin with their distinctive sloping profile. Front legs are significantly longer and more robust than hind legs, creating the characteristic appearance that hyenas are perpetually walking uphill. This disproportionate limb length, with front legs approximately 11 centimeters longer than rear legs, supports massive forequarters that house some of the most powerful jaw muscles in the animal kingdom. The skull structure of bone-crushing hyenas represents an engineering marvel, with massive, robust construction featuring pronounced sagittal crests that provide attachment points for enormous jaw muscles. High vaulting protects the skull against the tremendous forces generated during bone crushing, while shortened facial regions and inflated frontal bones create a head shape optimized for mechanical advantage. The jaw strength of spotted hyenas ranks among the most formidable in nature, capable of generating approximately 1,100 pounds per square inch of bite force. This crushing power, 40% greater than that of leopards and exceeding even the bite force of lions and Bengal tigers, allows spotted hyenas to crack open giraffe leg bones measuring 7 centimeters in diameter. Striped hyenas, while less powerful with bite forces around 800 pounds per square inch, and still splinter camel thigh bones, while young brown hyenas can crack springbok leg bones in 5 minutes. Though this ability deteriorates with age and dental wear, the teeth themselves represent specialized adaptations unique to the family, with the third premolar serving as a conical bone crusher found in no other mammalian family. These premolars work in concert with large carnassials positioned behind them, arrangement that allows hyenas to crush bones without blunting the sharp carnassial teeth needed for slicing meat. The digestive system of hyenas complements their bone-crushing abilities with one of the most acidic stomachs in the animal kingdom. This extreme acidity allows complete digestion of bones, breaking down even calcium phosphates and organic bone material that other carnivores must leave behind. A single adult spotted hyena can consume 1.3 kilograms of meat and bone per minute, with the ability to ingest up to 14.5 kilograms in a single feeding session. Groups of hyenas work with remarkable efficiency, with 35 individuals capable of devouring an entire adult zebra weighing 450 kilograms in just 36 minutes. Only horns, hooves and hair remain undigested, regurgitated as compact pellets similar to owl pellets. The feces of bone-crushing hyenas appear as chalk-white powder, rich in calcium phosphate salts, serving as a visible marker of their unique digestive capabilities and providing a means of redistributing these nutrients back into the ecosystem. The cardiovascular system of spotted hyenas reveals another remarkable adaptation that sets them apart from similar-sized carnivores. Their hearts are proportionately twice as large as those of comparable mammals, constituting approximately 1% of body weight compared to only 0.45 to 0.57% in lions. This enlarged heart provides the endurance necessary for sustained high-speed pursuits, allowing hyenas to maintain speeds of 60 km per hour for several kilometers. During nightly foraging expeditions, spotted hyenas commonly cover distances of 70 to 80 kilometers, While brown hyenas can travel up to 80 kilometers in a single night searching for food in the sparse Kalahari Desert, the aardwolf demonstrates impressive metabolic flexibility, capable of lowering its metabolism by 11% during winter, when termite availability decreases. Perhaps the most extraordinary anatomical feature unique to hyenas, particularly the spotted species, is the reproductive anatomy of females. Female spotted hyenas possess a pseudopenis, an elongated clitoris that can reach up to 8 inches in length. Externally indistinguishable from the male penis, the vagina is fused with urethra to form a common urogenital tract, and the labia form a false scrotum containing organized adipose tissue. This masculinization results from prenatal exposure to the androgen androstenedione, creating the most extreme example of female masculinization in any mammalian species. While this adaptation provides social advantages by reinforcing female dominance in the strict matriarchal society, it also creates significant reproductive challenges. Mating and birth must both occur through the narrow urogenital canal, approximately 1 inch in diameter, resulting in the most dangerous birth process in the animal kingdom. First-time mothers face mortality rates of 9 to 18%, while many cubs suffocate during birth due to the constricted passage. The social organization of spotted hyenas represents one of the most complex social systems documented in any carnivorous mammal. Clans range in size from 6 to over 130 members, with typical groups containing up to 50 adult females, 40 adult males, and 40 offspring. These clans function as cohesive units defending territories that vary dramatically in size depending on prey availability, from less than 40 square kilometers in the prey-rich Ngorongoro crater to over 1,000 square kilometers in the resource-poor Kalahari Desert. The defining characteristic of hyena society is its strict matriarchal structure, where every female and her offspring dominate every male, regardless of individual size or strength. The lowest-ranking female still outranks the highest-ranking male, creating a social hierarchy maintained across generations through a monarchy-like system of rank inheritance. Daughters inherit their mother's rank position immediately below her in the hierarchy, creating matrilineal dynasties that can persist for decades. Research spanning multiple decades in the Masai Mara revealed that top-ranked lineages experience dramatic growth advantages, with one lineage expanding from 2 females in 1988 to 21 females in 2014, representing a tenfold increase driven purely by the reproductive advantages of high rank. Almost every hyena, except the alpha queen, experiences downward mobility during their lifetime as higher-ranking lineages expand and push lower-ranking individuals further down the social ladder. Males disperse from their natal clans at approximately 2.5 to 3.5 years of age, joining new clans at the very bottom of the hierarchy where they must queue for status as higher-ranking males die or leave. Females, in contrast, remain in their natal clans for life, building lifelong relationships with relatives and allies that shape their success and survival. Despite forming cohesive social units, hyena clans operate as fission-fusion societies where clan members seldom occupy the same place at the same time. Subgroups form and dissolve multiple times per day, with over 60% of merge-split events either beginning or ending at communal dens, demonstrating that these sites serve as critical social hubs. Research published in 2024 showed that individuals are 4 times more likely to meet at dens and travel elsewhere together than to meet elsewhere and travel to dens, suggesting that dens function more as facilitators of encounters, as destinations for socializing pairs. This flexible social organization allows hyenas to adjust group sizes based on immediate needs, coming together for territorial defense or large kills while foraging individually or in small groups when hunting smaller prey. The cooperative abilities of spotted hyenas rival and in some cases exceed those of primates, the traditional exemplars of social intelligence. Research conducted at Duke University in 2009 revealed that hyenas outperformed chimpanzees on cooperative problem-solving tasks, requiring synchronized rope pulling to access food rewards. The first tested pair solved the novel technical problem in less than 2 minutes, demonstrating immediate understanding that both ropes had to be pulled simultaneously from the same platform. Experienced animals dramatically reduced solo attempts, showing clear awareness of their partner's essential role. Most remarkably, dominant animals displayed extraordinary behavioral flexibility, switching to submissive roles when paired with naive partners, an adjustment that chimpanzees struggle to make. Social factors strongly influenced performance, with pairs of dominant females often failing due to excessive aggression, while pairs with clear hierarchical relationships succeeded more readily. Field experiments in the Masai Mara confirmed these laboratory findings, with wild hyenas successfully solving novel puzzle boxes at rates similar to those of wild vervet monkeys. 62 hyenas were tested with puzzle boxes containing meat that required sliding a latch and swinging open a door, with 15% achieving success. The best predictor of problem-solving ability was not age, rank, or social connection, but rather the diversity of exploratory behaviors employed. Subsequent research demonstrated that problem-solving ability represents a stable, general trait in wild spotted hyenas, with performance remaining reliable across time and different contexts. These cognitive abilities appear linked to brain structures remarkably similar to those of primates despite more than 90 million years of evolutionary separation, representing convergent evolution driven by similar social challenges. The communication system of spotted hyenas ranks among the most sophisticated in the animal kingdom, incorporating vocal, chemical, and visual signals into a complex information network. The famous hyena laugh, more accurately termed a giggle, serves not as an expression of amusement but rather as a signal of frustration or submission, most commonly emitted when individuals are being attacked, harassed, or denied access to food. Detailed acoustic analysis published in PMC Ecology revealed that these high-frequency vocalizations encode multiple types of information simultaneously. Individual identity can be determined with 32% accuracy from giggles alone, far exceeding the 6% expected by chance, while the mean fundamental frequency drops from 650 Hz at age 2 to less than 450 Hz by age 20, encoding age information. Subordinate animals produce more variable giggles than dominant individuals, allowing listeners to assess the social status of unseen clan members. Beyond the giggle, spotted hyenas produce more than 10 distinct vocalizations, each serving specific communicative functions. The whoop, consisting of 6 to 15 calls over 30 seconds to 2 minutes, travels over 5 kilometers and serves as a long-range contact call for rallying clan members or announcing territorial ownership. Fast whoops, higher-pitched versions with shorter intervals, signal imminent attacks on lions or rival hyenas competing for kills. Grunts function as close-range greetings, groans welcome cubs at dens, yells express pain when bitten, and growls precede aggressive bites toward attackers. This vocal repertoire exceeds that of most other carnivores, with only domestic dogs and some primates displaying comparable vocal complexity and information content. Chemical communication plays an equally important role in hyena social life, with scent marking occurring through a behavior called pasting. Hyenas straddle grass stalks and extrude their anal scent pouches, dragging the exposed glands across vegetation and leaving thin layers of white, creamy secretion that produces an odour detectable by humans several meters downwind. Research published in Nature scientific reports demonstrated that these paste marks encode information about sex, familiarity, and individual identity, with males capable of discriminating between paste from different unfamiliar females. Gas chromatographic analysis reveals sufficient variation in fatty acid profiles for individual recognition, while members of the same clan show more similar scent profiles than those from different clans, suggesting a group odour signature. The fermentation hypothesis proposes that bacteria in scent glands generate odours through fermentation, with bacterial community structure varying by social group and creating clan-specific chemical signatures. Hunting strategies of spotted hyenas demolish the persistent myth that these animals are primarily scavengers. Comprehensive analysis of thousands of documented kills across 6 countries reveals that spotted hyenas obtain 60 to 95% of their food through direct hunting, not scavenging. Approximately 75% of hunting attempts are made by lone hyenas, even when targeting prey 3 times their body weight such as wildebeest and topi. Only zebra typically require group hunting efforts, with 10 to 25 hyenas needed to bring down these powerful equids. Overall hunting success rates hover around 33%, with solo hunts achieving 15% success and group hunts reaching 31% or higher depending on the coordination and prey species. These success rates match or exceed those of lions and demonstrate that hyenas are skilled, efficient hunters in their own right. The cursorial hunting style of hyenas relies on endurance and persistence rather than ambush tactics. Chases can cover distances from 75 meters to 5 kilometers, with average pursuit lengths of 5 kilometers for wildebeest and 3 kilometers for zebra. Hyenas maintain speeds of 50 to 60 kilometers per hour during these extended chases, facilitated by the flexible spines, specialized limb structure, and proportionately enormous hearts. Their acute hearing allows them to detect the sounds of other predators feeding from up to 10 kilometers away, while their exceptional sense of smell can track scent trails more than 3 days old and detect carcasses from distances exceeding 10 kilometers. Juvenile hyenas do not achieve adult hunting competency until 5 or 6 years of age, nearly 4 years after reaching sexual maturity, demonstrating the complexity of skills that must be mastered. Prey selection. Spotted hyenas shows clear preferences for medium to large ungulates in the 56 to 182 kilogram range, with the most common prey item weighing approximately 102 kilograms. Single hyenas commonly capture prey weighing around 100 kilograms, while cooperative hunting permits capture of animals up to 500 kilograms such as eland, and occasionally even larger prey like giraffes. Meta-analysis of over 3,000 documented kills shows that hyenas capture at least 30 different prey species across their range, with preferences varying by location and including blue wildebeest, zebra, Thompson's gazelle, impala, topi, springbok, gemsbok, and kudu. Only African buffalo and giraffe are significantly avoided, likely due to the extreme danger these animals pose even to groups of hyenas. The relationship between lions and hyenas represents one of the most intense competitive interactions in nature, with dietary overlap reaching nearly 69% in areas where both species coexist. Contrary to popular belief shaped by cultural stereotypes, lions steal from hyenas far more frequently than hyenas steal from lions. In the Ngorongoro crater, research documented that lions subsist largely on hyena kills, with over 80% of observed lion feeding events involving carcasses killed by hyenas. A comprehensive review of 13 studies across multiple sites found that hyenas lose 70% of their kills to lions, while lions lose only 35% to hyenas. Lions commonly kill hyena cubs and adults, with lions responsible for approximately 57% of hyena cub mortality in some areas. Male lions prove particularly dominant at competitive interactions, and the presence of even a single male lion can completely exclude hyenas from accessing food. Hyenas respond to lion threats through sophisticated mobbing behaviors involving cooperation among multiple clan members. Groups of hyenas approach lions in intimidating wedge formations, producing high-pitched whines and cackles designed to harass and overwhelm the larger predators. Mobbing rates peak at fresh kills where the food value justifies the risk of confronting lions. Success depends critically on the number of hyenas present and the number of coordinated mobbing attempts, with larger groups and multiple waves of harassment more likely to drive lions from kills. Despite outnumbering lions 3-to-1 in the Serengeti, hyenas typically defer to lions at competitive interactions, particularly when male lions are present. The competition extends beyond direct confrontations, with lions negatively impacting hyena populations through direct killing, food theft, competition-induced starvation, and exclusion from preferred habitats. Interactions with other large predators follow similar patterns of competition and occasional predation. Hyenas cause 21 to 57% of cheetah cub mortality depending on location, regularly steal cheetah kills, and represent a significant threat that cheetahs actively avoid through spatial and temporal separation. Cheetahs will aggressively defend against lone hyenas but flee immediately when confronted by groups. Leopards, despite being powerful predators, can be displaced from kills by hyenas on a 1-to-1 basis, leading to some degree of competitive avoidance. African wild dogs suffer approximately 5% mortality from hyenas, with hyenas raiding dens to prey on unattended pups and stealing kills from wild dog packs. The high energy expenditure required for wild dog hunting makes even small food losses to hyenas unsustainable over time, and in some areas, high densities of lions and hyenas prevent wild dog establishment entirely. The reproductive biology of spotted hyenas reflects the unique challenges imposed by their unusual anatomy and complex social structure. Females experience estrus for only 3 days per year, during which males perform elaborate bowing displays to solicit mating. Females maintain complete control over reproduction, with copulation occurring only if the female accepts the male's advances. Males behave timidly during courtship, immediately retreating if females show any sign of aggression. Mating typically occurs only at night when no other hyenas are present, lasting 4 to 12 minutes, with successful conception followed by a gestation period of approximately 110 days. Litter sizes range from 1 to 2 cubs typically, though up to 6 are possible under optimal conditions. Birth represents the most dangerous moment in a hyena's life, for both mother and offspring. The narrow urogenital canal, approximately 1 inch in diameter, must accommodate cubs weighing 1 to 1.5 kilograms. First births frequently cause a clitoral tissue to tear and rupture, leading to maternal mortality rates of 9 to 18% for first-time mothers. Cubs that survive birth emerge remarkably well-developed compared to other carnivores, with eyes already open, dark brown to black fur covering their bodies, and fully erupted teeth including the 6 to 7 mm canines and 4 mm incisors. This advanced development serves immediate survival needs, as cubs begin aggressive competition with siblings within hours of birth. Same-sex litters experience particularly intense sibicide, with the dominant cub frequently killing its sibling during the first weeks of life when both are confined together in the natal den. Maternal care in spotted hyenas represents the most intensive investment documented in terrestrial carnivores. Cubs nurse exclusively on their biological mother's milk for 12 to 18 months, the longest lactation period of any carnivore. Spotted hyena milk contains the highest protein and fat content of any terrestrial carnivore, with lactating females carrying 3 to 4 kilograms of milk in their udders. Mothers typically remain away from communal dens except when nursing, making regular visits to provide this crucial nutritional support. Cubs can begin processing solid food by 3 to 5 months of age, but continue nursing well past their first year. This extended dependence, combined with the approximately 24-month interval between successful litters, means that female spotted hyenas invest more energy per cub than any other terrestrial carnivore, with profound implications for lifetime reproductive success. The inheritance of social rank from mother to offspring follows a process remarkably similar to that documented in Cercopithecine primates, despite the evolutionary distance separating these groups. Through repeated interventions on behalf of their offspring during aggressive encounters, mothers establish their cubs' ranks immediately below their own in the hierarchy. Cubs learn to recognize their own position and that of every other clan member through associative learning during their first years of life. This inherited rank determines nearly every aspect of an individual's life trajectory, including growth rate, survival probability, age at first reproduction, and ultimately, lifetime reproductive success. High-ranking offspring grow faster, survive at higher rates, reproduce earlier of shorter intervals between births, and see their own offspring survive at elevated rates compared to low-ranking individuals. Research demonstrates that spotted hyenas underperforming their inherited ranks during formative months are approximately 1.5 times more likely to die at any given point, illustrating the profound importance of successfully establishing one's social position. The geographic distribution of hyena species reflects both their evolutionary history and contemporary conservation challenges. Spotted hyenas once roamed across Africa, Europe, and Asia, with cave hyenas inhabiting regions from the British Isles of far eastern Asia until the end of the late Pleistocene approximately 12,000 years ago. Today their range is restricted to sub-Saharan Africa, from Senegal and Somalia in the north to northern South Africa in the south, though they remain absent from the rainforests of the Congo Basin. Their remarkable adaptability allows them to occupy habitats ranging from savannas and grasslands to woodlands, subdeserts, and mountains up to 4,000 meters in elevation. Striped hyenas maintain the widest distribution of any hyena species, extending from North Africa through the Middle East, Arabian Peninsula, Caucasus, Central Asia, and into the Indian subcontinent, though their current distribution is patchy and indicates increasingly isolated populations. Brown hyenas occupy the most restricted range of any hyena species, confined to the arid regions of southern Africa including Namibia, Botswana, South Africa, and portions of Zimbabwe, Angola, Mozambique, and Eswatini. The largest populations persist in the southern Kalahari Desert and along coastal areas of southwest Africa, particularly the skeleton coast of Namibia, where unique populations have adapted to marine scavenging. Aardwolves maintain two geographically separate populations divided by approximately 1,500 kilometers, with one population in eastern and northeastern Africa extending from extreme southeastern Egypt through Ethiopia, Somalia, Kenya to central Tanzania, and a second population in southern Africa encompassing Angola, Namibia, Botswana, Zimbabwe, Mozambique, South Africa, and Zambia. This disjunct distribution reflects the specialized nature of aardwolf ecology, which is determined entirely by the presence of their preferred prey, Triinivetums termites. Habitat requirements vary dramatically among species and locations. Spotted hyena territories range from less than 40 square kilometers in the pro-rich Ngorongoro crater to over 1,000 square kilometers in the resource-poor Kalahari Desert, with intermediate values of 44 to 72 square kilometers documented in the Serengeti. Brown hyena territories are consistently large, ranging from 233 to 466 square kilometers, reflecting the sparse distribution of food resources in their arid habitats. Striped hyenas show less territorial behavior than their spotted cousins, with overlapping home ranges of 44 to 72 square kilometers and frequent movements between multiple den sites. Aardwolves maintain much smaller territories of 1 to 4 square kilometers per individual or breeding pair, with densities reaching up to 1 adult per square kilometer in prime termite habitat. Among the highest densities achieved by any hyena species, den sites serve critical functions beyond simple shelter, acting as social hubs, nurseries, and territorial markers. Spotted hyenas establish communal dens in protected locations and serve as focal points for clan activity, with cubs remaining at these dens for 12 or more months before joining hunts. Striped hyenas prefer rocky hills, caves, fissures, and erosion channels for den sites, often appropriating burrows originally excavated by porcupines, wolves, warthogs, or aardvarks. Den complexity varies with location, ranging from simple refuges to elaborate tunnel systems extending up to 27 meters in length. Brown hyenas select hidden den locations in remote sand dunes or among rocks, carefully positioned to avoid overlap with spotted hyena and lion territories. Aardwolves utilize underground burrows, frequently occupying existing structures created by aardvarks, porcupines, or spring hares, and typically relocate to new dens every 6 to 8 weeks. Access to water shapes distribution patterns differently across species. Spotted hyenas require regular access to water sources and drink nightly when available, a constraint that influences territory selection and seasonal movements. Striped hyenas demonstrate greater tolerance for arid conditions, drinking nightly when water is available but capable of surviving extended periods. Without water in desert environments, brown hyenas have achieved near-complete independence from standing water, meeting their moisture needs by consuming fruits with high water content such as tsama melons, gemsbok melons, and hookery melons. This adaptation allows them to persist in some of the driest regions of southern Africa, while the large carnivores cannot survive. Aardwolves similarly can survive in areas lacking readily available water, meeting their hydration needs entirely through consuming termites, which provide sufficient moisture for their relatively small bodies and specialized low-energy lifestyle. The conservation status of hyena species presents a mixed picture of relative stability and concerning decline. Spotted hyenas maintain their classification as least concern on the International Union for Conservation of Nature Red List, with global population estimates of 27,000 to 47,000 individuals based on data collected in 2014. However, this designation masks significant declines occurring outside protected areas, particularly in eastern, central, and western Africa, where habitat loss and human persecution have dramatically reduced populations. Key strongholds include the Serengeti ecosystem with 7,200 to 7,700 animals, Kruger National Park with 1,300 to 3,900 animals, and the Ngorongoro crater, which supports one of the highest density hyena populations on Earth. The overall population trend remains declining despite the least concern classification, raising questions about whether the current assessment adequately reflects the challenges facing the species. Striped hyenas face more immediate conservation concerns, classified as near threatened with fewer than 10,000 mature individuals remaining globally and populations continuing to decline across most of their range. Their distribution has become increasingly patchy and fragmented, particularly in West Africa, the Sahara, Middle East, Caucasus, and Central Asia, suggesting isolated populations vulnerable to local extinction. The species receives additional classification as vulnerable in the Middle East, reflecting particularly acute threats in that region. A notable exception to the overall decline occurs in Israel, where striped hyena populations increased by 68% over 47 years, reaching densities of 2.1 individuals per 100 square kilometers. This recovery resulted from increased prey availability following changes in waste management and livestock practices, combined with the extinction of competing leopards, demonstrating that hyena populations can recover when threats are reduced. Brown hyenas carry the distinction of being the rarest hyena species, with only 4,000 to 10,000 individuals surviving in the wild and a general classification of near threatened on the International Union for Conservation of Nature Red List. The United States Fish and Wildlife Service maintains a more precautionary stance, listing brown hyenas as endangered since 1970. Country-specific estimates reveal the limited distribution of remaining populations, with Botswana supporting the largest numbers at 2,800 to 5,300 animals, Namibia harbouring 566 to 2,400 individuals, and South Africa home to approximately 1,000 brown hyenas. The species faces the additional challenge of extremely low genetic diversity, with all sampled individuals showing identical mitochondrial DNA sequences, indicating severe historical population bottlenecks, out of eroded genetic variability and potentially compromised adaptive capacity. Aardwolves represent the most secure hyena species, classified as least concern, with stable population trends across most of their range. Population estimates remain unavailable due to the difficulty of surveying these nocturnal, elusive animals that maintain naturally low densities. Even in optimal habitat, aardwolf densities never exceed 1 individual per square kilometre, and across much of their range, densities are considerably lower. The stable classification reflects both genuine population stability and the species' ability to persist in human-modified landscapes, where termite populations remain viable. However, localized declines occur in areas where intensive agriculture destroys termitaria or where pesticides used for locust or termite control reduce prey availability. Road mortality represents an additional concern, with 301 aardwolves documented as roadkill in South Africa between April 2013 and December 2016, suggesting that vehicle collisions may represent a more significant mortality source than previously recognized. Human-wildlife conflict represents the primary threat facing all hyena species, driven by perceived or actual livestock predation and resulting in widespread persecution through shooting, spearing, trapping, poisoning, snaring, and hunting with dogs. Wire snares alone kill approximately 400 spotted hyenas per year, while brown hyenas face frequent retaliatory killing despite limited evidence that they regularly prey on large livestock. Striped hyenas are actively encouraged to be killed on sight in some Middle Eastern regions, and even aardwolves, which pose no threat whatsoever to livestock, suffer persecution due to mistaken identity with their bone-crushing relatives. This conflict stems partly from legitimate economic concerns of subsistence farmers who cannot afford livestock losses, but also reflects deeply rooted cultural prejudices that cast hyenas as evil, cowardly scavengers associated with witchcraft, grave robbing, and supernatural threats. Habitat loss and fragmentation increasingly constrain hyena populations as agricultural expansion and human settlement convert lateral grasslands and woodlands into farmland and urban areas. This conversion simultaneously depletes prey bases and termite populations, while restricting the available territory that hyena clans require for sustainable foraging. Roads fragment, remaining habitat and increase vehicle collision mortality, with brown hyenas particularly vulnerable while scavenging roadkill along highways. Isolated populations face elevated extinction risk due to genetic bottlenecks, reduced breeding opportunities, and inability to recolonize areas following local extinctions. The effects compound across landscapes, with small, isolated populations showing reduced genetic diversity, increased inbreeding, and decreased adaptive capacity to environmental changes. Poisoning, both intentional and unintentional, represents an insidious threat that affects hyenas across their ranges. Farmers intentionally place poison bait near livestock to kill predators, while collateral damage from predator control programs targeting jackals and caracals frequently kills hyenas that consume poisoned carcasses. Pesticide use for locust and termite control poses particular threats to aardwolves, whose specialized diet makes them vulnerable to any reduction in termite populations. Secondary poisoning occurs when hyenas consume animals that have ingested pesticides or when they feed on poisoned baits intended for other species. The effects often go undetected, as poisoned animals typically die away from human observation, making assessment of poisoning's full impact difficult. The hunting of hyenas for body parts used in traditional medicine and rituals adds pressure to already stressed populations. Striped hyenas face particular demand, with skins and body parts believed to possess medicinal or magical properties in certain cultures. Brown hyenas similarly suffer hunting pressure for use in traditional practices, while spotted hyenas face illegal trade despite legal protections in many countries. These traditional uses intersect with cultural beliefs associating hyenas with supernatural powers, creating complex conservation challenges that require engaging with traditional knowledge systems and belief structures rather than simply imposing external conservation frameworks. Climate change represents an emerging threat whose full impacts remain uncertain but potentially severe, particularly for specialized species occupying marginal habitats. Aardwolves face particular vulnerability, as shifts in grassland communities and termite distributions could render large portions of their current range unsuitable. Brown hyenas, already operating at the margins of survival in desert environments, may face increasing water stress and prey scarcity as arid regions become more extreme. Changes in seasonal rainfall patterns affect prey migrations and abundance, with cascading effects on predator populations. The interaction between climate change and other stressors such as habitat fragmentation and human persecution may create threshold effects where populations that appeared stable suddenly collapse when environmental conditions shift beyond tolerable ranges. Cultural perceptions of hyenas have shaped human attitudes and behaviors toward these animals for millennia, generally to the severe detriment of hyena conservation. Ancient Greek philosophers like Aristotle and Roman naturalists like Pliny the Elder provided relatively neutral descriptions, but early Christian texts such as the Physiologus depicted hyenas as hermaphrodites and grave robbers, comparing them to double-minded men who vacillate in their faith. Medieval Becheries elaborated on these themes, illustrating hyenas feeding on human corpses and emphasizing their necrophagous habits. These negative portrayals intensified through the 18th and 19th centuries, with European naturalists and explorers emphasizing scavenging behavior, perceived cowardice, and supposedly ugly appearance. 20th century popular culture continued these stereotypes, with Ernest Hemingway's writings and Disney's The Lion King portraying hyenas as gluttonous, stupid, and cowardly villains. African folklore presents complex and varied perspectives on hyenas, ranging from negative associations with immorality and witchcraft to neutral or occasionally positive roles in creation myths and ecological narratives. West African traditions often portray hyenas as symbols of immorality, dirty habits, and reversal of normal social order, with Bang folklore from Côte d'Ivoire depicting them as bad Muslims challenging local animistic beliefs. East African cultures associate hyenas particularly strongly with witchcraft, with Mbugwe traditions from Tanzania claiming that every witch owns hyenas as night cattle, riding them during nocturnal journeys. Kaguru and Kujamat peoples view hyenas as inedible, greedy hermaphrodites, while Gogo folklore links hyenas to the origin of death, claiming they prevented humanity from achieving immortality through their actions in primordial times. The were-hyena mythology, parallel to werewolf beliefs in European traditions, remains particularly widespread across Africa and the Middle East. Ethiopian blacksmiths were historically believed to transform into hyenas at night to rob graves, with this belief contributing to discrimination against Ethiopian Jews who were accused of being Buddha, or were-hyenas. In the Bornu Empire near Lake Chad, entire villages were supposedly inhabited by were-hyenas who lived as humans during the day before transforming at night. Somali traditions describe the Corius Maris, men who transform using magic sticks, while similar beliefs persist in Sudan, Morocco, and Tanzania. These supernatural associations, combined with a persistent hermaphrodite myth based on the female spotted hyena's pseudopenis, continue to influence contemporary attitudes and complicate conservation messaging. Conservation efforts addressing hyena decline operate at multiple scales, from international coordination through the International Union for Conservation of Nature Species Survival Commission, hyena specialist group, to local community-based initiatives reducing human-wildlife conflict. The specialist group, currently chaired by Dr. Stephanie Deloniac, coordinates research and conservation action through projects including comprehensive distribution mapping, species distribution modeling, threats assessment, and red list evaluations. The distribution mapping project, currently updating range maps last completed in 1998, will provide crucial baseline data for assessing population trends and targeting conservation interventions. These international efforts establish frameworks and priorities that guide more localized conservation programs implemented by government agencies, non-governmental organizations, and community groups. The African Wildlife Foundation has operated a large carnivore research project since 2002, studying hyena populations, behaviours, movements and human interactions across Botswana, Namibia, Zambia and Zimbabwe. This research informs the development of conservation actions designed to reduce conflicts while maintaining viable predator populations. A particularly successful intervention involves constructing predator-proof livestock enclosures called bomas, using strong metal fencing to protect animals from nocturnal attacks. These structures reduce livestock losses dramatically, decreasing the economic incentive for retaliatory killing while allowing hyenas to persist in human-dominated landscapes. Orn Free implements similar boma construction programs through partnerships in Kenya, particularly through the Pride of Ambossi team, and in Meru National Park, demonstrating scalable, cost-effective solutions that benefit both people and wildlife. Carnivore Research Malawi has pioneered urban hyena conservation through intensive study of spotted hyenas living in Lilongwe, the capital city. This research examines how hyenas adapt to urban environments and how people can coexist with these powerful predators in close proximity. The organisation operates a wildlife assistance helpline providing free advice to communities experiencing human-wildlife conflict, implements an extensive desnaring program removing deadly snares from hyena habitats, and provides veterinary care for injured animals through partnership with the Lilongwe Wildlife Trust. Educational programs disseminate practical guides on livestock protection while building local capacity through training students and community members. A Women in Science program specifically addresses gender disparities in conservation professions while engaging communities in research and monitoring. Species-specific conservation projects provide focused attention to the unique needs of different hyena populations. The Brown Hyena Research Project, based in Luderitz in southern Namibia's Namib Desert, has operated since 1995 studying the ecologically unique coastal brown hyena population. These animals, adapted to marine scavenging along the Skeleton Coast, face particular threats from coastal development and disturbance. The Botswana Predator Conservation Trust addresses human-carnivore conflict through innovative economic mechanisms, including the Shorob Livestock Insurance Initiative, a community-administered insurance program that compensates herders for livestock losses while incentivizing non-lethal coexistence strategies. In Turkey, Wild Track collaborates with Sutsu Imam University using footprint identification technique for non-invasive monitoring of striped hyenas, engaging local community tracking skills in conservation science. Korongosa National Park in Mozambique recently implemented a hyena reintroduction program, translocating animals to restore ecological balance in an ecosystem recovering from decades of civil war. 6 new hyenas were added during 2022 and 23 to earlier translocations, with successful breeding documented in 2023 when cubs were born to the reintroduced population. This project, implemented through partnership among Mozambique Wildlife Alliance, the National Administration of Conservation Areas, Keringani Game Reserve, and the Lion Recovery Fund, demonstrates that hyena populations can be restored to areas where they have been extirpated, provided that habitat and prey remain viable and human attitudes support coexistence. Protected areas provide crucial refuges where hyena populations can persist without the intense persecution faced in human-dominated landscapes. Serengeti National Park in Tanzania and Kruger National Park in South Africa support some of the largest remaining spotted hyena populations, while Etosha National Park in Namibia and the Central Kalahari Game Reserve in Botswana provide critical habitat for brown hyenas. The Ngorongoro Conservation Area supports one of the most studied and dense hyena populations in existence, with research conducted over 27 years providing unparalleled insights into hyena ecology and behaviour. However, protected areas alone cannot ensure hyena persistence across the historic ranges, as many species require territories larger than existing reserves and must utilize surrounding landscapes where they encounter human activities and associated threats. Education and awareness initiatives represent essential components of comprehensive hyena conservation strategies, addressing the deeply rooted cultural prejudices and misconceptions that drive persecution. Programs in schools teach children about hyenas' ecological importance, emphasizing their role as efficient hunters rather than lazy scavengers, their crucial ecosystem services through nutrient recycling and disease control, and their remarkable intelligence and complex social behaviors. Community engagement programs involve local people in conservation decisions, develop alternative livelihood opportunities through ecotourism and sustainable agriculture, and foster collaborative approaches to human-wildlife coexistence. The European Association of Zoos and Aquaria coordinates captive breeding programs for striped hyenas, with 91 animals housed in 38 institutions as of March 2023, providing both genetic reservoirs and opportunities for public education about these misunderstood carnivores. The evolutionary history of hyenas illuminates both their remarkable adaptations and their current conservation challenges. The family Hyenidae diverged from civets approximately 24 million years ago during the early Miocene epoch, with early ancestors resembling modern African civets inhabiting the jungles of Eurasia. Pleoviverps, one of the earliest identifiable species dating to 20 to 22 million years ago, was a lithe, civet-like animal distinguished by its middle ear structure and dentition. From these humble origins, hyenas diversified into two distinct evolutionary trajectories that dominated different ecological niches across 3 continents. The dog-like hyenas evolved first, developing lightly built, nimble bodies adapted for cursorial hunting. This lineage peaked approximately 15 million years ago with over 30 species identified, outnumbering all other carnivores combined at some Miocene fossil sites. Examples include Ictotherium vivarinum, a jackal-like species that thrived across Eurasia. However, this lineage declined dramatically between 7 and 5 million years ago due to climate change and competition from true canids that were simultaneously diversifying and improving their cursorial adaptations. Most dog-like hyenas went extinct by 1.5 million years ago, with only the aardwolf surviving as a highly specialized insectivore at abandoned competition with canids entirely by switching to termites as exclusive prey. The bone-crushing hyenas arose 10 or 40 million years ago, coinciding with the decline of an earlier group of bone-crushing carnivores called percrocutids. These robust predators evolved the powerful jaws, specialized teeth, and acidic digestive systems that characterize modern spotted, brown, and striped hyenas. They became the undisputed top scavengers of Eurasia and Africa, capable of processing entire carcasses including skeletal elements that other carnivores must abandon. The largest bone-crushing hyena, Pachycriceta brevirostris, weighed approximately 110 kilograms and roamed Eurasia during the Pleistocene. Spotted hyenas dispersed from Africa approximately 2.5 million years ago, concurrent with early human migrations, establishing populations across Eurasia that persisted until the end of the late Pleistocene, roughly 12,000 years ago. Cave hyena fossils are superabundant in Western European cave deposits, suggesting these animals thrived in Ice Age ecosystems alongside mammoths, woolly rhinoceroses, and Neanderthals. The phylogenetic relationships of hyenas reveal surprising connections that contradict their superficial resemblance to dogs. Despite dog-like appearance and behavior, hyenas belong to the suborder Feliformia, making them more closely related to cats, civets, and mongooses than to any canid. The carnivore order split into dog-like and cat-like lineages approximately 50 million years ago, with hyenas arising from the cat-like branch. Hyenas last shared a common ancestor with mongooses and civets roughly 30 million years ago, making these small carnivores their closest living relatives despite dramatic differences in size and ecology. The behavioral and morphological similarities between hyenas and canids result entirely from convergent evolution, as both groups adapted to similar ecological roles as cursorial predators, that catch prey with teeth rather than claws, eat food quickly without prolonged processing, and maintain social groups for cooperative hunting and defense. The remarkable success of hyenas across millions of years of evolutionary history, occupying diverse habitats from tropical forests to Arctic tundra during their Pleistocene expansion, stands in stark contrast to their current conservation status. 3 of 4 species face declining populations and increasing threats, with 2 classified as near threatened and 1 officially listed as endangered by some authorities. The spotted hyena, while maintaining a least concern classification, has lost 24% of its historic range in the last 40 years despite being among the most adaptable and resilient large carnivores. This decline occurs not because hyenas cannot adapt to changing conditions. Their evolutionary and ecological success demonstrates remarkable adaptability, but because human persecution driven by cultural prejudice and economic conflict actively eliminates them from human-dominated landscapes. The intelligence that allows hyenas to solve novel problems, the social complexity that rivals that of primates, and the ecological flexibility that permits survival across diverse habitats cannot overcome sustained human hostility. Every night, hyenas die in wire snares set by humans, consume poison baits placed to protect livestock, or face bullets from farmers defending their herds. These deaths accumulate gradually, depleting populations outside protected areas, while fragmenting remaining strongholds into isolated patches increasingly vulnerable to local extinction. The extreme genetic bottleneck documented in brown hyenas, where every tested individual shares identical mitochondrial DNA, illustrates how severe these population reductions have become, eroding the genetic diversity that populations need to adapt to future environmental changes, including climate shifts already underway. Yet hope persists in the success stories emerging from locations where conservation interventions address both approximate causes of human-hyena conflict and the underlying cultural attitudes driving persecution. The 68% increase in Israeli striped hyena populations demonstrates that when direct persecution decreases and prey availability increases, hyena populations respond positively. The thriving spotted hyena population in Lilongwe, Malawi's capital city, proves that even these powerful predators can coexist with dense human populations when communities receive support managing conflicts and education about hyena ecology. The successful breeding of reintroduced hyenas in Gorongosa National Park shows that populations can be restored to areas where they were extirpated rebuilding the ecological connections that these animals provide as both predators and scavengers. The ecological services that hyenas provide justify conservation efforts on purely functional grounds, independent of ethical considerations about species preservation. Hyenas process carrion that would otherwise serve as disease vectors, removing dead animals that could spread anthrax, rabies, and parasitic infections through scavenger communities. Their bone-crushing abilities allow them to consume entire carcasses, redistributing nutrients locked in skeletal calcium back into ecosystems through their distinctive white feces. As predators, they control herbivore populations, preventing overgrazing that degrades grassland and savanna ecosystems. Their selective predation on sick, injured, and juvenile animals removes individuals most likely to succumb to disease or predation anyway, improving the overall health and genetic quality of prey populations. The social intelligence documented in hyenas provides additional justification for conservation beyond their ecological roles. These animals demonstrate cognitive abilities that illuminate the evolution of intelligence itself, showing that complex social reasoning, cooperative problem-solving, and sophisticated communication can evolve in carnivore lineages just as they have in primates. The convergent evolution of primate-like brain structures and cognitive abilities in an evolutionary lineage separated from primates by more than 90 million years demonstrates that social complexity and intelligence represent adaptive solutions to similar ecological challenges rather than unique features of primate evolution. Research on hyena cognition informs understanding of mammalian brain evolution, social organization, and the environmental pressures that select for enhanced cognitive abilities. The misunderstood predators that emerged from the Miocene jungles of Eurasia, diversified across 3 continents, survived ice ages and interacted with Neanderthals in Pleistocene caves, now face their greatest challenge in the Anthropocene. Their persistence depends not on their own adaptability, which remains remarkable, but on human willingness to share landscapes with animals that cultural traditions have cast as villains for millennia. Conservation success requires transforming deeply rooted prejudices, addressing legitimate economic concerns of subsistence farmers, and rebuilding ecological understanding of hyenas' crucial roles in healthy ecosystems. The fate of hyenas, whether they thrive in protected strongholds while disappearing from human-dominated landscapes, or persist across their historic ranges through successful coexistence strategies, will be determined by human choices made in the coming decades. These choices will reflect not only on the conservation status of 4 unique carnivore species, but on humanity's capacity to coexist with wildlife whose survival depends on our tolerance, understanding, and willingness to share an increasingly crowded planet.